Hi everyone, I just wanted to give you some more direction for the chromosome modeling. And those of you that were at home kind of missed some of this, so I wanted to give it to you in a little video. So you're either going to draw out or print out the chromosome template. But what you need first is you need two chromosomes. These chromosomes are found in your nucleus, and they have DNA within them, all super coiled up to form these chromosomes, and the chromosomes are what are going to go through the different stages of meiosis, just like in mitosis. So first things you need to do is pause the film and cut out one chromosome from mom and one chromosome from dad. So you have two chromosomes. So take a second and pause and cut those out. We then are going to put on here different genes, okay? So you need to have 6 genes on mom. So you could do hair color, eye color, skin color, tall or short. You could do height. You could do maybe one for, we were talking about a widow's peak or hairline. You could do one for certain type of earlobes. Whatever 6 you put on this one, you're going to put on this one in the same exact spot. So maybe you put blue eyes for mom, brown eyes for dad. Brown hair for mom, black hair for dad. Short, tall. Earlobes attached, earlobes detached. You can put whatever you want. Maybe mom and dad both have blue eyes. You're going to put them on here. Now, in class, we used symbols to showcase our genes. And we did that by using letters. Now, we showcase these with letters, like let's say this is blue eyes. This is a big B, big B. Actually, that would be brown eyes probably. Big B, big B. We talked about dominant and recessive genes. So if you think about in the world, a dominant gene for eye color is probably a brown eye. So if it's a dominant gene, we would do big B, big B. If it was a recessive gene, oh, here we go. Here's a recessive gene. They did little b, little b. So they have them in the same exact spot. So if you're confused with that, then you want to make sure that you you can use just the letters, or you can use the full words if it helps you. All right, some of these are a little bit off on this model, so I'm going to pick a different model because that one's not really correct. Let me find one that looks good here. Okay, we'll find a mom and a dad. Let's see. Oh, here we go. This one looks correct. Here we go. We have big B, and big B, little b. Okay, so this one has a dominant, and this one has a dominant and a recessive, but the recessive takes over. So then they did their next letters. They did LL. Maybe that's for like, maybe it's for like left-handed or something. Who knows? Okay, so you can put that either the letters in here, or you can just write the words. Okay, so once you have your 2 chromosomes, one from mom, one from dad, before they go and separate, they have to make copies. So we have to make what's called a tetrad. So mom needs a copy. That would be a sister chromatid. Let me find mom's copy. Here it is, her exact copy. Same one. And then dad needs a copy. Let me find dad's exact copy. BB, where are you? Here it is. Okay. So we have our first set was a homologous pair. Then each one makes a copy. And now we have a tetrad. We have 4. So let's look at the directions on our sheet. Insert image of your chromosome with genes here. So you would just insert a picture of your chromosome with different genes on it. Okay. Then it says identify 3 pairs of homologous chromosomes. Describe where each one comes from. One comes from mom and one comes from dad. insert homologous chromosomes here. So you have your picture, you can insert your pair now. Now it's said to make 3 pairs. So here's 1 pair. Then we have another pair with all new fresh genes on it. So maybe you have a gene for intelligence, and a gene for athletic, a gene for baldness. Each one of these are going to be 6 new genes on here. So this is 1, 2, and they made another one. There's another mom and dad. 3 pairs, okay? So you should take a picture of your 3 pairs and put it here. Now each pair gets a sister chromatid. So this one has 4, that's a tetrad. This one has 4, that's a tetrad. This one has 4, that's a tetrad. So you have 4, 4, 4. The homologous pair is 1 from mom and 1 from dad. And then when they duplicate, when they synthesize and make more DNA, they are in a sister chromatid. Okay? So all together you should have 12 chromosomes. You should have, your tetrad should have same genes, but like mom could have blue eyes and dad could have brown. And then each tetrad should be different genes on it, okay? So insert image of your chromosome, sister chromatids here, and then you're done. Okay, so all you had to do first, was make a mom and a dad, give them both sisters, that's a tetrad. On mom, put 6 genes. On dad, put 6 genes. The eyes line up, the hair lines up, and then lay them out 4, 4, and 4 with your 12 chromosomes. Okay, so hopefully that helps. That was the last step at where we were at, and then when I get back next week, we're going to focus on learning how to cause that variation through different ways that you can see variation in all of us. Why do you not look exactly like your mom? Or why do you not look exactly like your dad? Bye, guys!